Hello, this is Chemistry Final Exam Review number 3. So video number 3. For this review, you're going to need your second quarter test review problem sheet. All right, we're gonna just work chapter 7, starting with this limiting reactant problem. You'll want a periodic table. All right, you're going to need your calculator. All right, and then I'll talk about a couple of other things at the end of the video that you can work for additional practice. Okay, so our first problem is a limiting reactant problem. Now, this actually isn't in Chapter 7. It's really a Chapter 6 type of problem, but our book doesn't cover it, and it's a very important subject. So, reading through Chapter 7, number 1, we have this chemical equation, P4 plus 10Cl2 yields 4PCl5. If 10 grams of P4 and 30 grams of Cl2 are reacted, determine the final mass of product made, the limiting reactant, the mass of the excess reactant remaining, and the percent yield if 25 grams is actually collected. So all that a limiting reactant problem is a stoichiometry problem. It's a stoichiometry problem where we're trying to find how much a product is made based on how much of the reactants we have. So the stoichiometry equation that we went over in the last video review, the stoichiometry review, applies to the limiting reactant problem. And it's going to be 4 sets of parentheses. We're going to go from grams of substance A all the way to grams of substance B. So the first thing that we want to do is see how much PCl5 is made if we start with 10 grams of P4, our first reactant. So we have 10 grams of P4. Put that over 1. All right, so we're right here, grams A. We need to go to moles A. So we go to moles of P4. And the unit we put on the bottom is go up 1 and to the left, grams of P4. The 1 goes by the mole when it's moles in something else. And we need to add up P4 on the periodic table. Well, each phosphorus weighs 31. All right, so 31 times 4 will be 124 grams. All right, so we're here at moles of substance A. Now we need to go to moles of substance B. Well, that's PCl5. So let's put that on top. Moles of PCl5. We're canceling out moles of P4. All right, up to the left, that'll tell you where those two have to match. And we use the stoichiometric coefficient, so we have 4 in front of PCl5 and a 1 in front of P4. All right, and finally, we need to get to grams of PCl5. All right, so the 1 goes by the mole. Where are we going to get grams of PCl5? Well, we have to add it up from the periodic table. We have 1 phosphorus, that's 31, and 5 chlorines at 35.5 each. All right, so if you add that up, you'll get 208.5. Be careful. Don't rush through the adding up process because that'll cause you to miss the problem. Okay, so in your calculator, 10, divide that by 124, times 4, divide that by 1, but you don't have to because it's 1, times 4, times 208.5, you'll get 67.26 grams of PCl5. Now, is that the answer? I don't know. don't know, let's check Cl2. Well, we're starting with 30 grams of Cl2. All right, we need to go to moles of Cl2, so 1 mole of Cl2. Each Cl2, if you look at the periodic table, weighs 35.5, so that would be 71. 2 times 35.5. Now we go to the stoichiometry. We're going to PCl5, so moles of PCl5. We need to cancel out moles of Cl2. Well, the stoichiometric coefficient in front of PCl5 is 4, in front of Cl2 is 10. All right, so one more. We don't have to do any work. We know that PCl5, if you added it up right the first time, is 208.5. And then we get rid of moles of PCl5. And the 1 will go by the moles. So in your calculator, you can work along with me. 30 divided by 71 times 4, and hit equal every time. All right, divided by 10, and then times 208.5. That's 35.24 grams of PCl5. The amount of product made is the lesser of the two. Okay, so question 1, or question A, says the final mass of the product made. So if I can try to write that up here, that's going to be 35.24 grams of PCl5. What is the limiting reactant? That's question B. Well, it's the reactant that made the lesser of the two amounts, and that's Cl2. So that's the limiting reactant. All right, question C is, what is the amount of excess reactant that remains? Well, the excess reactant is P4. It's the other one. This one ran out. It stopped when we got 35.24 grams of PCl5. All right, so P4, we'll call this excess P4. Okay, so where you start is at 35.24 grams of PCl5. Because that's how much got made in this reaction. Right, you just start on the excess reactant part, you just start right there. So think of PCl5 now as grams of A. And then we've got to go to moles of A. So moles of PCl5. We need to cancel out or get rid of grams of PCl5. When you have moles in something else, you put the moles by 1 by the moles. You've already added up PCl5. It's right up here and right up here, 208.5. So you don't have to do that work again. Now we're at this step, the stoichiometry step, going from moles of PCl5 to moles of P4. All right, moles of P4. Let's get rid of moles of PCl5. All right, so moles of P4, we're going to use the stoichiometric coefficient. That's just 1 in this reaction. Moles of PCl5, that's 4. All right, we're almost home. Now we need to go to grams of P4. Now this would be the grams of P4 that got used up. One goes by the mole. How much does P4 weigh? Well, you added it up here. You can add it up again. It's 31 times 4, but if you'll look up, it's right in the problem, 124 grams. So you'll take 35.24 divided by 208.5 times 1, which you don't really have to do, divided by 4 times 124. That'll get 5.24 grams. Now that's not the answer. That's how much got used up in this reaction. So how much is excess? Well, what did you start with? You started with 10 grams. Subtract out how much you used, 5.24 grams. And what is remaining is 4.76 grams. Alright, so this reactant, Cl2, ran out first. All 30 grams ran out first. This was the excess reactant. We only used up a little over 5 grams. So what's left? 4.76 grams. So let's put that up here. 4.76 grams of P4. Alright, the last question, question D, is percent yield. All right, percent yield, you take the amount of product from the question. It said 25 grams is actually collected. This 35.24 grams is if every single molecule collide and react, and that never happens in the real world. Okay? In the real world, some molecules just simply don't collide and react. So you only actually collected 25 grams from the problem. This is what if every single molecule collided and reacted, what you would have, 35.24 grams times 100. And that'll give you a percent of 70.9%. So that's telling you I'm 70.9% efficient if I can do a better job of mixing these reactants so that more react, maybe raise the temperature, mix better, more will react, and I'll get a higher percent yield, then I have a more efficient process. All right, pause the video if you need to, and we will go through the next 4 questions in Chapter 7 review, and it'll go much faster than this. All right, so that is it for the stoichiometry part of the review. Now, I do have a couple of limiting reactant problems that you can work. If you will look in your review packet, I have 2 extra limiting reactant problems. So use the example I just did, work these 2 problems, and you should be a total expert on these limiting reactant problems, and you'll be able, if I put one on the final, you'll be able to absolutely get it. The answers are at the bottom of the page, so just work through. And if you're struggling with this, let me know on Microsoft Teams, and I'll see if I can help you. All right, so the next question is determine the number of protons, neutrons, and electrons in molybdenum 80. That's how you say it, molybdenum 80. That 80, all right, so if you have molybdenum 80, that 80 is the total number of protons plus electrons. Excuse me, I'm so sorry. Protons plus neutrons. That's the total of protons plus neutrons. Well, how do you get the number of protons for molybdenum? All right, well, we have to find molybdenum on the periodic table. All right, so molybdenum is number 42, so it has 42 protons. How many electrons does it have? The same amount, 42. Because it's an atom, not an ion, that hasn't lost or gained electrons, so 42. How do you get how many neutrons? You take this number, 80, and subtract the number of protons, 42. All right? And that is going to give you 38. All right, so that is all there is to it. 42 protons, 42 electrons, and 38 neutrons. Okay, that's definitely one you do not want to miss. Such easy points on the final exam. Okay, so let's look at number 3. Number 3 says determine the energy of light that has a wavelength of 750 nanometers. Well, we have two equations that we have to remember. The energy equation is E is equal to hf. And then the frequency equation, F is equal to the speed of light over the wavelength. Now the speed of light will be given to you. It's 3 times 10 to the 8th meters per second. Planck's constant, h, will be given to you. All right, Planck's constant is 6.63 times 10 to the minus 34 joules per hertz. Those will be given to you. All right, so you also need to remember that 1 nanometer is equal to 10 to the minus 9 meters. That will not be given to you. Okay, so we'll need to use that in a minute. So it says we have a wavelength of 750 nanometers. What's the energy? Well, first of all, we need to get the frequency, knowing the wavelength, and then we will plug it into this formula. So frequency is equal to the speed of light over the wavelength. That's 3 times 10 to the 8th meters per second divided by, now it's given to you in nanometers, so we have to convert that to meters. So 750 times 10 to the minus 9 meters. If it's given to you in meters, you don't have to do this conversion. But since the speed of light is in meters per second, we have to convert the wavelength into meters. All right, I'm going to go through how to put this in your calculator because we did have some students struggle with that. Not many, but a couple. So 3 second function double E, 3 second function double E, an E will show up, and then 8. Don't type in times 10. Divide by 750 second function double E. If you have a TI 84, just go. You'll be able to find the double E, and then that's to the negative 9. All right, the answer is 4 times 10 to the 14th. All right, 4 times 10 to the 14th. The unit is hertz for frequency. So 4 times 10 to the 14th hertz. Now we can plug that number into frequency. So E is equal to Planck's constant, 6.63 times 10 to the minus 34 times 4 times 10 to the 14th hertz. All right, let's put that in the calculator. 6.63 second function double E minus 34 times 4 second function double E to the 14th. Don't type in times 10. 2.652 times 10 to the minus 19 All right, what is the unit for energy? It's joules. All right, so for these types of problems, you can be given energy and have to solve for frequency. You can be given wavelength have to solve for frequency. You just need to algebraically manipulate these equations. If frequency is c over wavelength, then wavelength is equal to c over frequency. Frequency is equal to E over Planck's constant. You may have to rearrange these. Just practice a couple of those from chapter 7. Practice problems or extra practice problems to get a little more experience with these. All right, that's number 3. Let's see if we can finish this up with number 4 and 5. So number 4, I'm going to need to remind you, it's the electron configuration. So we have S block, that's these 2 columns. We take helium and put it right into that column. D block, the transition metals in D block right here. And then P block right over here. Okay, these 1, 2, 3, 4, 5, 6 columns right here. Okay, F block we won't be dealing with, but that's down here. Okay, so the first question says, what is the, or excuse me, number 4 says the full electron configuration of arsenic. All right, well, full means we have to go the entire way. So you'll be given a periodic table like this. It won't be labeled with the blue. So you'll have to know that this is S block, and that this is S block, this is P block, this is D block. All right. Arsenic's right here, so we've got to go find arsenic. So we've got 1s2, then we come down to 2s2, 2p6, 1, 2, 3, 4, 5, 6. Energy level 3s2, crossover energy level 3p6, we're to argon. Then we go 4s2, we have to subtract an energy level when we get to D. So 4 minus 1 is 3, 3d10 to zinc, and then back to energy level 4, 4p3, 1, 2, 3. All right, so it's going to be 1s2. Remember the coefficient out front, and then you have a superscript. 2s2, 2p6. Then we're at an energy level 3, 3s2, 3p6 gets us to argon. Then we go to energy level 4, 4s2. Now if you're looking at your periodic table, we're at calcium. Subtract an energy level. A few of you forgot to do that on the take-home test for chapter 7. Subtract an energy level 3d10. So we've made it to zinc, 3d10. And then add back the energy level when we get back to the P block, 4p. And it is 1, 2, 3. So 4p3. We know that arsenic has 33 electrons, so you can add these up. 2, 4, 10, 12, 18, 20, 30, 33. So we think that we're on the right track. You'll want to practice doing a couple of those. These are easy. You want to get these points on the final exam. All right, and then we want to do the abbreviated electron configuration for tellurium. All right, we got to find tellurium. Where in the world is tellurium? Well, here it is, number 52. What you do is you go to the noble gas that precedes tellurium, that's krypton, and you put that in brackets. That way we get to start at krypton. We get to skip everything before krypton. Then we come down here to energy level 5, 5s2, subtract an energy level, 4d10. All right, so we've made it to cadmium. Right? 5s2, 4d10, and then go back to 5p, 1, 2, 3, 4. So 5s2, Right, 5s2, we're at strontium. 4d10, we've made it to cadmium. Don't forget to drop that energy level. And then 5p, 1, 2, 3, 4. Okay, that does it for chapter 7 and our third review video. This is what you need to do. First of all, work the extra limiting reactant problems. Work that from that worksheet that I showed you earlier. All right, and then work the suggested chapter 7 problems. All right, what are the suggested problems? Well, they're on the sheet. In chapter 5, our suggested additional problems were practice problems 4 through 10 and extra practice problems 6 and 8 through 13. For chapter 6, the suggested problems were the second half of the stoichiometry worksheet, practice problem 8 through 10, extra practice problems 1 through 10. And in chapter 7, the suggested additional problems are the limiting reactant worksheets, practice problems 1, 4 through 6, 8, and 9, and extra practice problems 1 and 3 through 9. Don't work them. If I don't list it, you shouldn't work them. You don't waste your time on it. Now, you can refer back to, when you're working those from the textbook, refer back to this sheet. All right, because I put all the answers on this sheet. You don't have to go hunting through your notebook to find the homework answers. I gave them to you, okay? So just use this. Message me if you have a problem and you need some further help. That'll do it for this video. We have one more video to come to review chapters 8 and 9, and I will talk to you then.